Hello everyone, welcome back to your own mathematics channel asm.geniusjunction. I am Abhishek sir, your mathematics mentor. In today's video, we are going to cover paper 6 of 9709 mathematics, unit 2 Poisson distribution. This is your video number 2 and this video is in continuation with video number 1. So those who have still not gone through with video number 1 are suggested to go through with video number 1 first so that you can effectively understand what we have covered in this video. The topic which are to be covered in this video are adapting Poisson distribution for different intervals. So without wasting time, let's start how we proceed in these types of questions. Poisson distribution. In a Poisson distribution, events occur at a constant rate. The mean average number of events in a given interval is proportional to that. Let's understand what this particular expression means mathematically. So let's take a situation, right? So now what is a situation which we need to understand over here is let 3 patients arrive in a clinic in every 10 minutes. Okay. Now, if I ask you if 3 patients are arriving in 10 minutes, then in 1 minute, how many patients are arriving in the clinic? So your answer is going to be 3 over 10 patients. So this is your answer for 1 minute. Okay. Now we can change the interval as we need. Okay. So suppose if the question asks us, I'm writing it over here, suppose time interval required. If the time interval required in the question becomes 20 minutes, then I will write 3 over 10. This is your number of patients arriving in 1 minute and this will give me 6 patients. So I will write that initially X was following a Poisson distribution with number of patients arriving in the clinic as 3 in every 10 minutes, and now for 20-minute period the Poisson distribution has changed and now it has become Poisson distribution. X follows Poisson distribution with mean as 6. In a similar way, suppose the time interval required, in question is 4 minutes. Okay. So first of all, we need to understand that 1 minute time interval is 3 over 10 patients. So 4 minute time interval is going to be 3 over 10 times 4, and this will give you answer as 1.2. So I will write that now X follows Poisson distribution with mean as 1.2 patients for 4-minute interval. So this is very important to understand that whenever we will be doing a question which is based on Poisson distribution, we need to change the Poisson distribution according to the time interval which is shared in the question. Okay, so let's understand this particular topic in detail in the questions which are ahead of it. These are Poisson distribution based question, and in these questions we need to change the time interval as per the demands of the question. So let's go through with this question number 1 and let's see what all is given to us in this particular question. So the question says the number of breakages at a restaurant in a randomly chosen week can be modeled as random variable having a Poisson distribution with mean as 0.8. Please do not forget that this particular data is given as randomly chosen week. Now work out the probability of the following. What they want you to calculate is exactly 1 breakage in a week. There is no problem because he is asking about 1 breakage in a week. In the second part, he is asking exactly 1 breakage in the randomly chosen 3-week period, right? And the third question becomes equally interesting because B part he's saying the manager offers a staff a bonus if there are no breakages in a 6 consecutive weeks. What is the probability that the staff receives the bonus? So staff will receive the bonus if there is no breakage in 6 consecutive weeks. This is a very good question. So let's start solving this particular question. Okay, so after reading the question, we can easily figure out that x is actually following a Poisson distribution with mean as 0.8. Okay, in part A, he's saying that work out the probability that exactly one breakage is there in a week. So it means that we need to calculate probability of x is equals to 1. So this is very simple. It is going to be e raised to the power minus 0.8 bracket. I will write 0.8 raised to the power 1 over 1 factorial, and finally when I will solve this using calculator I will get 0.359. So first part of the question is done. Let's move on to second part of this particular question, where it is saying exactly one breakage in a randomly chosen 3-week period. Okay, so time interval is changed to 3-week period. Yes, so now we need to change the time interval for this particular question. Okay, so we can see that in first part it is given that for 1 week time interval, when it was 1 week it was 0.8. so just continuing with the same thing, if it is a 3-week period it is going to be equals to 0.8 times 3, and this is going to give me 2.4 as the final answer. So now I will say that x follows Poisson with mean as 2.4, and now I have changed the time interval according to 3-week period. So now let's solve this. Question says that exactly one breakage in a 3 randomly chosen week. So this is probability of x is equals to 1 again, and this time it is going to be e raised to the power minus 2.4 bracket 2.4 raised to the power 1 over 1 factorial. By using calculator we can easily see that this is going to be equals to 0.218. So now the final answer for the given question becomes 0.218. In exactly similar way, we will move on to B part of it. Okay, so in part B, we will write that according to question, manager will offer a bonus if there is no breakage in first week, there is no week breakage in second week, there is no breakage in third week, again keep doing this, there is no breakage in the fourth week also, fifth week also, and sixth week also. So question manager is saying that if there will be no breakage in all these 6 consecutive weeks, so there will be a bonus for the staff. Okay, so first of all we will convert the Poisson distribution initially from 0.8 to 6-week interval. So if I convert this particular Poisson distribution in a 6-week interval, this is going to become x follows Poisson with 6 times 0.8, and which actually gives me answer as 4.8. Now I need to calculate the probability when x follows Poisson with 4.8 as mean, and they want you to calculate probability of x is equals to 0 in it. So I will write it as e raised to the power minus 4.8 bracket 4.8 raised to the power 0 over 0 factorial, and when I will solve this, finally we will get the answer as 0.00823. So yes, this is going to be the final answer for the given question. In the next question, yes. So in this question again, we are given the number of faults in a roll of a wallpaper can be modeled as a random variable having a Poisson distribution with mean 0.6. So in this question again, we are given the mean equals to 0.6. Find the probability that a decorator using 4 rolls of the wallpaper for a room finds no fault in the wallpaper. So let's start with the solution of it. So first of all, we will write that for one roll of wallpaper which is there, x is actually following Poisson distribution and the mean is given to us as 0.6. Okay. Now if we read the question very carefully, he's saying that the decorator using 4 rolls of wallpaper, right? So first of all, we need to understand that same wallpaper is used 4 times. So probability of x having no fault is equals to e raised to the power minus 0.6 times 0.6 raised to the power 0 over 0 factorial. This is equals to e raised to the power minus 0.6 only. Okay, and now since a decorator is using 4 rolls, so therefore probability of no fault in 4 rolls of wallpaper becomes equals to e raised to the power minus 0.6 raised to the power 4, and this gives you the final answer as 0.0907. This is the answer for the given question. Quickly note these solutions so that we can move on to next part of the question. Okay, so now we have reached on one more very good level question based on the concept of Poisson distribution applied on different intervals, and this question states that the number of cars passing a point on the road can be modeled as a random variable having a Poisson distribution with mean is 2 cars per 5 minutes. Okay, now in part A, he wants you to understand what is the probability in a randomly chosen 20-minute period that more than 3 cars will pass through that given point. B part says that what conclusion might you draw if no car passes through that point in the given 20-minute interval. And C part says that how might installing a traffic light at one end of the road affect the Poisson distribution model. Okay, so let's solve this question. Now in this question, first of all, the data says that x follows Poisson distribution with mean as 2 cars in every 5-minute interval. Okay, so more precisely, if I write it, I can write it as x follows Poisson with mean as 2. Okay, so in part A, question is saying that what is the probability in a randomly chosen 20-minute period. So first of all, for 20-minute period, there will be a change in the mean. So 20-minute interval, we will change the original data accordingly. So we will write for this as 1 minute is equals to 2 upon 5 cars. Okay, so it implies that for a period of 20-minute interval, this is going to become 2 over 5 times 20. That gives you 4 times 2, that is 8 cars in a 20-minute interval. Okay, so now let's read the question very carefully and figure out what they actually want us to calculate. So question says that what is the probability that in a randomly chosen 20-minute period more than 3 cars will pass that point on the road. Question says that what is the probability that there will be more than 3 cars which will be passing on the road. So we know that we are going to calculate as 1 minus probability of x is equals to 0, 1, 2, 3. So I will write it as 1 minus e raised to the power minus 8 bracket 8 1 plus 8 plus 8 raised to the power 2 over 2 factorial, and then 8 raised to the power 3 over 3 factorial, bracket close. When we will calculate this, our final answer is going to be 0.958. So this is the final answer for part A on the given question. What conclusion you might draw if no car passed that point randomly in a 20-minute period? Okay, so what question is saying to you is there is no car passing through that particular point since last 20 minutes. So what can be the possible reason for the given particular situation? I can say that the time interval selected for the observation might be of midnight when there is very less traffic. Okay, so this can be the possible reason that the time interval selected is belonging to the night time when there is very less traffic. That might be the reason that there is no car since last 20 minutes over there. Now part C says that how might installing a traffic light at one end of the road affect the Poisson distribution? Now if you read this particular part 3, this is very simple. If you apply a traffic light at one end of the road, then the flow of the traffic is definitely going to change. When the light is going to turn green, there will be more number of cars in the given time interval, and when it will be red, then there will be lesser number of cars passing through the given particular point in a given space of time. So I will write that after installing the traffic lights on the road, the flow of traffic is going to change, and hence it will not be random, and then probability Poisson distribution will not be applicable. Okay, so let's move on to next question now. Now we have reached on the next question where again we are going to change the time interval of the Poisson distribution according to the requirement of the question. So let's read the question first and then we will figure out what we need to do. Over a period of time, a consumer complaint department notes that it receives an average of 4.2 emails per hour. So what assumption do you need to make to model this particular number of email complaints received by the consumer complaint department as Poisson distribution? So first thing is they want us to know that what can be the possible assumptions for modeling this particular situation by Poisson distribution. In the second part they are saying why might it be likely that all the complaints are made independently of each other. Okay, so we need to give the possible answers for this one. Then in part C he's saying are complaints more likely to be made at certain times rather than others. In the third part he's saying assuming the number of emails received can be modeled as Poisson distribution, find the probability that the consumer complaint department receives 9 emails in 2 hours and 3 emails in minute. So let's solve this particular question by using Poisson distribution concept. So this is the solution for the given question. First of all, let's quickly write down that x follows Poisson with mean as 4.2 mails per hour. Okay, so more precisely if I write it in a simplified way, I can write that x follows Poisson with mean as 4.2. Right here 4.2 represents mails per hour. Now first part says that what assumption do you need to make to model the given situation by Poisson distribution. So I will write the answer as emails received by the department, emails received by the department must be random and occurring independently. It is very important that the number of emails received by the departments are independent of each other, right? So this is the assumption which is taken into this particular question. Now, okay, so B part says that why might it be unlikely that all the complaints are made independent of each other? So we will say that the complaints received can be varied as the faulty product might generate large number of complaint emails, right? If there will be a faulty component, so there will be large number of complaint emails regarding this. So these things are unlikely to be independent of each other. Okay, now C part, what C part is conveying to us? So part C says that are complaints more likely to be made at a certain time rather than other? I will say yes, definitely. The complaints received are less likely to be made outside the normal working hours, right? Normal working hours. Okay, so this is all for part C. Now let's move on to part D, which is a very important one. In part D, he's saying that assuming the number of emails received can be modeled as Poisson distribution. So it means that X is following Poisson with number of mails received as 4.2. Find the probability that the consumer complaint department receives 9 emails in 2 hours. So we will change this accordingly for 2 hours because question is talking about 2 hours. So I will write it as X follows Poisson with 4.2 times 2, that is 8.4. And now he wants you to calculate probability of 9 emails in 2 hours, that is probability of X is equals to 9. So I will write it as e raised to the power minus 8.4 times 8.4 raised to the power 9 over 9 factorial. Let's quickly solve this, and when we will solve, we will get the final answer for the given question as 0.129. Okay, similarly, this is a part 1 of the given question. Now in part 2, he's saying 3 emails per minute. Okay, so part 2 is saying probability of X is equals to 3 emails in a minute. So question is saying that we need to find the probability that he will be getting 3 emails in a minute. So first of all, we need to convert X, which follows Poisson, for 4.2 mails in a hour to 1 minute interval. So for 1 minute interval, the Poisson is going to change itself as X follows Poisson with mean as 4.2 over 60. Okay, so that gives me answer as X follows Poisson with mean as 0.07. Okay, so now we need to figure out the question. 3 emails per minute. So I will write X, probability of X is equals to 3 emails in a minute, that is probability of e raised to the power minus 0.07 times 0.07 raised to the power 3 complete expression divided by 3 factorial. So when I will solve this, the final answer for the given question appears to be 0.0000533. So this is the final answer for the given question. Okay, so let's move on to next types of questions which can come up from this particular topic. Yes, so now I hope that you all are able to understand how to change the time interval for the Poisson distribution according to the question. Please practice all the questions which are discussed in this particular video, and so that you can effectively understand the concepts which are going to be taught in the next video. Till then, keep practicing. Have a good day.